Hi, everyone. In today's Stoichiometry Lab, we're going to be putting into practice some of the things that we've been learning about over the last few days. In our lab today, we're going to be combining acetic acid, which looks like this. It's just a clear solution, with sodium bicarbonate, which is like this, a white powder. And you probably better know these each as vinegar, commercial vinegar like we would get at a supermarket. And this is baking soda. Okay, so we are all familiar with that reaction. What we're going to be doing today basically is some stoichiometry behind that reaction. So let's take a look at our first part here. So just like you, I'm going to be following along with this lab procedure. And as we go through the different parts, I'll try and make sure to show everything up close that I'm doing, so you can really get a sense what it's like to do this lab. Okay, I'm going to begin by putting on my goggles to protect my eyes here. We are using heat. We're using some glassware, so we want to make sure that we protect ourselves. And the other thing that we're going to do is always make sure that we're wearing closed-toed shoes. That way, in case anything were to spill off of the lab bench, or if we were to drop anything on the floor, our feet are going to be protected. Now, up here, I just want to point out a few things. So this is our hot plate that we're going to be using to perform the lab here. This is our balance, which we're going to be using to weigh out our material. We have our weighing dish. We have our evaporating dish, which we'll use later on. We have our watch glass. We have our crucible tongs, which is what we're going to use to move around our hot glassware. And we have our solution and our sodium bicarbonate powder. Okay, let's go ahead and get started. So in step number 1, it says obtain the mass of a dry evaporating dish and watch glass and record the mass in your data table. So at this point, here is our evaporating dish, which is dry, and here is our watch glass. And the reason why we're getting the mass of both the evaporating dish and the watch glass is that when we are done with our reaction, our watch glass is going to be completely coated with material, so we will not be able to get its mass separate from each other. So we're going to get the mass of both of these together. So if you notice, my balance is set to 0 grams. I can put both of these on our balance, and we're going to record our mass as 75.79 grams in our data table. Okay, the next thing it says that we're going to do is we're going to add about 2 to 3 grams of sodium bicarbonate to our evaporating dish. So if you notice, we're at 75.78. So 2 to 3 grams is somewhere around 77.78 and 78.78. So let's put in about 2 to 3 grams. If you can put it in without touching the material, that's better. The reason is that prevents us from contaminating the entire container of substance. Okay, so we are at 77.50 grams. I'm just going to try and add just a little tiny bit more here. Perfect. We are now at 77.84 grams. Now, if we go back and look at our procedure here, it says slowly add 20 milliliters of acetic acid to the sodium hydrogen carbonate in the evaporating dish. Then carefully add additional acetic acid from the dropper until the bubbling stops. So we're going to begin by adding some acetic acid. So basically, we want to make sure that we add enough so that all of our sodium bicarbonate has reacted, but not so much extra that it's going to take us longer to evaporate off our solution. So we're going to start by adding 10 milliliters at a time. So this is our first 10 milliliters. So if you notice, and I don't know how clear this is showing up on the video, but if you notice, you can certainly hear the sound of sodium bicarbonate and acetic acid generating those bubbles of carbon dioxide. We'll go over the equation for this later on. So I'm now adding my next 10 milliliters. We're just going to allow that to react for a minute or so. We don't care about the mass at this point because we have added an excess of the acetic acid solution. So we're not concerned about the mass at this point. So I'm using a glass stirring rod here to just kind of mix together any of the unreacted sodium bicarbonate with any of the unreacted acetic acid. I'm going to lift this up toward the camera here. It's kind of difficult to see because it's not exactly clear. However, trust me that there is still some, you can kind of see it a little bit. There's still some unreacted sodium bicarbonate in here. So I'm able to mix that around. You can tell if we're still getting some bubbling, that means there's still some unreacted material in here. So I'm going to add just 5 more milliliters. Of our acetic acid solution. So you can hear that it once again started bubbling. Pretty vigorously, which seems to indicate, again, that there's still unreacted sodium bicarbonate in here. So I'm going to continue mixing. So our solution looks pretty clear now, indicating that all of our sodium bicarbonate has now been reacted. You also see almost no bubbling whatsoever, even as I mix this pretty vigorously here. Okay, at this point, I am going to move on to our next step. So in step number 4, it says place the evaporating dish on the hot plate, place the watch glass concave side up so that there is room for steam to escape. So we want the watch glass to be placed on it like this, so concave side up. So the rounded part is actually going to sit down into the evaporating dish. And what will happen is as the water evaporates, it's going to condense on this watch glass. It's going to run into the center and fall back down. Now, eventually that water will reach a temperature where it escapes through this opening on the side here and leaves as a gas. Now, when it leaves as a gas, it's not going to carry any of our sodium acetate solid with it. So that will remain in our evaporating dish. So I'm going to turn this on here. So just so you know, there are 2 sides to these hot plates. One is a stirring mechanism, which is over here on the right side. This is the heating mechanism on the left. So we can heat it. Now, this is the temperature that this metal plate will reach. This is not necessarily the temperature inside of the solution, but we definitely want to make sure that we get it to a temperature that is above 100 degrees Celsius, right? As soon as the hot plate top becomes hot, this light will turn on here. I'm just teaching you a few things about using this. So when you turn this off, this will say hot and off to remind everyone that, yeah, even though it's not heating anymore, that surface is still hot. Okay, so I'm going to once again turn it back on to about 300 degrees. Now I'm going to time lapse this for you, so that way you're not sitting here watching this the entire time. But wow, it almost looks as if it has disappeared, but I assure you that my evaporating dish and hot plate are there. Change the camera angle here so you can see it a little better. There you go. Okay, so I'm going to let that sit for a little bit. We're going to heat it up, and I'll time lapse this so you don't have to watch it. And when we're all done, I'll talk to you again. So I just want to speak a minute here. So now the solution has passed its boiling point. So you'll notice the steam coming out from over here. I'm not sure how well you can see it. Ooh, sometimes you can see it really well. And then inside of our evaporating dish, we obviously have water evaporating. It is condensing on the top and falling back down. We're going to turn down our heat just a little bit here. So to speed up this process a little bit, I have removed the watch glass from the top. Okay, as you can see, we're down to the final amounts of liquid in our evaporating dish. So we're just going to leave that on there for just a tad bit longer. I try and move this around, try and get any water that's left in there out. And we're just moving this solid that we produced here. And try and get this as dry as possible. This is what it looks like from this angle. Again, we're continuing to heat even at this point. I'm just continuing to break up any large clumps that I see that might still have some moisture in them. We're now going to move this on top of our watch glass. We're going to allow this to cool before we get our final mass. Okay, we can now take our watch glass and our sample, and we can transfer it to our balance. And we find out that we have a mass of 77.66.